Welcome to FactSpark. By many, deserts are considered one of the most hostile environments to be found on our planet. Extreme temperature changes, virtually no vegetation to sustain human life, exceptionally little precipitation, bare rock and sand surfaces as far as the eye can see. All of these factors make it nearly impossible to sustain human life for an extended period. At the same time, however, these barren landscapes bear some of the most extreme creatures, geographical features, and environments on the planet. The first fact clarifies which kind of environments we are talking about in this video when using the word desert. As with many geographical features, there's no universal definition of what a desert is. To set the boundary for this video, I'll guide you through the 4 most common types of deserts. While all of these types share the feature of having very low precipitation, they all have other distinct features of their own. Hot deserts. Striking features of hot deserts are places with extremely high evaporation due to temperatures beyond 40 degrees Celsius all year round. There are no noticeable seasons, and the day-night cycle brings extreme temperature changes with it. This can, for example, be the Sahara or most of Australia. Semi-arid deserts. This kind of desert is a little less extreme in the day-night cycle and can experience a hint of seasons throughout the year. Semi-arid deserts, however, are not limited to hot areas and instead can also be found in colder environments like Newfoundland, Russia, or the subarctic. Coastal deserts. The coastal desert is thought to be the least threatening kind of desert out of these 4. It refers to spaces with more moderate temperatures, but still very low precipitation. This combination of temperatures and precipitation can be found near oceans, as the name suggests, or in between mountain ranges. Famous examples are the Atacama or the Namib Desert, cold deserts. Cold deserts share the feature of having dangerously low precipitation, with an average of around 150 millimeters annually. Additionally, they stand out with very low temperatures during the winter times, while summers can be mild. Famous examples of these are the Gobi Desert in Mongolia and China, as well as parts of Antarctica. Since this is clarified now, let's look at some extreme specimen of these desert types. One place on Earth stands out when looking at the amount of precipitation it receives, since it's the only place on Earth known to be without water since around 14 million years. The so-called dry valleys on Antarctica are surrounded by mountains of sufficient height to block any inflowing ice or snowy clouds. At the same time, catabolic winds of around 320 kilometers an hour heat up when rushing down the steep mountain sides, which instantly blows away and evaporates any possible precipitation. While this exceptional place is an anomaly on Earth, there are many other deserts that experience nature's forces with higher intensity. While low precipitation is a main requirement for an area to be considered a desert, it will still occasionally experience rainfall, and due to the nature of deserts, these often result in flash floods. Year-round low humidity has dried out the soil over large areas, and missing vegetation has given the ground time to solidify. Sandy grounds with dunes are also not very effective at absorbing surface water. These conditions now prevent falling rainwater from being absorbed in the ground, which can bring blessing but also devastation. While the resulting flash floods can sweep away entire villages, they also mean the only source of life to special animal and plant species with rapid germination. For fact 4, we're moving from the threats of sudden bursts of water to sudden bursts of wind. Again, these threatening natural formations are caused by the already extreme features of hot deserts. Steady winds pick up grains of upper layer sand and blow them over the desert floor. Every time these particles touch down on the ground, tiny dust fragments break off and then suspend in the air. In the moment where just a bit stronger winds from pressure gradients pick up these particles together with small sand grains, a massive sandstorm can start. Sandstorms are most prevalent in the Sahara Desert, specifically in the Baudelaire Depression in the center of Chad. An average of 100 sandstorms occur from here every year. For fact number 5, we're actually staying in the Baudelaire Depression. Even though you probably haven't heard about the Baudelaire Depression before, it plays a major role in the world's most diverse biosphere. The depression used to be a giant lake, so its sediment ground contains many minerals from fossilized algae. These algae make up a large percentage of the dust, which gets carried all the way over the Atlantic to fertilize the Amazon rainforest. The exploitation of these fertile lands, coupled with global warming, brings us to our sixth fact of the episode. Desertification describes the degradation of formerly fertile land to a level where no more vegetation can thrive. This occurs in already arid areas, on the edges of all hot deserts around the world, and leads to a size increase of deserts. This subsequently decreases potential food sources as well as living spaces for the people in the area, and can have devastating effects to health and environment, especially since many of these people already live in poverty. The American Meteorological Society has measured the increase of the Sahara to be 10% within the last millennia. The continuing expansion of this rate can cost lives of millions. For the last fact of the episode, we'll finish up on a happier note. After all the life-threatening natural phenomena in and around the desert of this world, they also offer a huge potential, of which the population around can benefit. The so-called sun continent has an enormous threshold of continuous sunshine all year round, together with nearly endless open and rather flat land which can be utilized. With drastically decreasing manufacturing costs of advanced photovoltaic collectors, Africa might soon become an electrical powerhouse. To put this into numbers, the extremely high annual solar energy flux in Africa lets any photovoltaic system harvest around twice as much energy as the same system would in Germany. I hope you have learned something. Thanks for watching, and see you for the next episode.